Hi everyone, my name is Eliamje Ben David and I'm a network solution engineer at Alcatel-Lucent Enterprise. The reason why I'm sitting in Sydney Harbour is that, like the bridge behind me, ILE OmniAccess Stellar access point and OmniSwitches connects people. In today's session, we will focus on network access control and the bridge between ILE network solution and Forescout technology. So stay tuned and let's get into it.
Before we begin this demo, if you are interested in a deeper dive into the integration between ILE and the Forescout NAC solution, I highly recommend downloading our latest implementation guide. This guide provides detailed insight into how OmniAccess Stellar and OmniSwitch work seamlessly with Forescout CounterACT, all through OmniVista. It also highlights key use cases for this integration. You can find the document on Spacewalkers, the ILE Network community website. There, you also discover additional resources, forums, and best practices related to Alcatel-Lucent enterprise technologies and networking. In this session, I'll start with a brief introduction to the interoperability with Forescout. Next, I'll walk you through the lab architecture used in this demo, followed by an overview of today's use case, 802.1x authentication with posture assessment. From there, we'll dive into the demo itself and we'll wrap up with some key takeaways about the integration. Let's take a moment to talk about Forescout and their powerful platform, CounterACT. Forescout is a leader in network security, offering solutions that ensure organizations to have complete visibility and control over all devices connected to their networks. The flagship platform, CounterACT, is a robust network access control solution designed to address the challenges of modern IT environments. It provides comprehensive device visibility, granular network access control, automated policy-based enforcement, and intelligent segmentation. What sets Forescout CounterACT apart is its agentless operation. This means it can monitor and secure both managed and unmanaged devices across IT, IoT, and OT environments, offering unmatched versatility. By integrating with other security tools, CounterACT enhances an organization's security posture through automated threat detection, incident response, and compliance enforcement. It's built to adapt to evolving network landscapes, giving businesses the agility and insight they need to manage complex ecosystems with confidence. What's even more exciting is how seamlessly this NAC solution integrates with Alcatel-Lucent Enterprise's network solutions. Whether it's OmniAccess Stellar access points, OmniSwitches, or OmniVista Network Management System, Forescout CounterACT works effortlessly with ILE's technologies. This integration simplifies deployment, enabling organizations to leverage the power of ILE solution while benefiting from CounterACT's advanced visibility and control feature. Together, these solutions offer a secure, scalable, and efficient approach to managing and protecting your network. For this demonstration, I've set up a small lab environment to highlight the capabilities of ILE and Forescout. In this lab, I've deployed the Forescout CounterACT appliance, the OmniVista 2500 network management system, and a Windows server handling Active Directory, DHCP, and DNS. To interconnect the devices and manage the network effectively, I've included an OmniAccess Stellar access point and an OmniSwitch. The network is segmented into two VLANs, one for management traffic and other for user data. I'll be connecting to the network with the Windows server. Here is an overview of the use case I'll be demonstrating today. 802.1x authentication with posture assessment, leveraging the UPAM module in OmniVista as a proxy radio server. In this scenario, we'll start with a Windows client running Forescout Secure Connector, an agent that enables Forescout to gather information about the endpoint and report its status. This endpoint will connect to the network via our Stellar access point using an SSID configured in OmniVista with 802.1x authentication. The AP sends a radius access request to UPAM. UPAM then acts as a proxy, forwarding the request to Forescout. Forescout processes the request. It verifies the shared secret to ensure the request is from an authorized client, check that the authentication method is allowed, and validates the user credential against Active Directory. If authentication is successful, Forescout checks for any matching policy before granting or denying access. For this demonstration, we'll have policy in place that require a secure connector to perform posture check on the endpoint. If the endpoint passes the posture check, Forescout sends a radius access accept response back to OmniVista with a filter ID value of domain users. If the endpoint fails, Forescout sends an access accept response with a filter ID value of quarantine. OmniVista receives the access accept response and forwards it to the Stellar access point. The API then maps the filter ID to a predefined access flow profile, either granting conventional access for compliant devices or quarantining non-compliant ones. Now, let's dive into how we can configure this in our lab environment. We will start by the configuration that needs to be done on Forescout. First thing first, we need to add OmniVista as a network access device. To do so, you need to get to Option and click on the wireless module. Here we can see that instead of adding OmniVista, you could have also added your switches and access points directly. Using OmniVista as a proxy offer radius monitoring features and avoid having to add all your network devices separately. To add OmniVista, click on Add, and in the General section, select Radius Only Management for the product, Generic for the NAS vendor, and add the OmniVista IP address. Then, in the 802.1x section, configure the radius secret that you will share later in the OV configuration, and click on Finish and Apply to save the change. Then, let's go to the radius module. Here, we will define the authentication source on which Forescout will verify and validate our endpoint during authentication. Here we can see that we have added an Active Directory running on our lab Windows server. Then, go into pre-admission authorization and create a new rule. This rule will be used to define the condition for the radius module to process a radius access request it received. Click on Add and then add a condition. Select the attribute NAS identifier. Configure this NAS identifier with matches the expression. This expression will have to be the name of the SSID you're about to configure on OmniVista. And then, once done, click OK and apply the new radius configuration. Back on the Forescout homepage, let's go in Policy. We will create a policy for Forescout to evaluate endpoints and apply specific treatment after they have been authenticated, but before they get access to the network. On the policy page, click on Add. From here, you can select a template policy or create a custom policy. Forescout offers multiple templates, whereas you want to do policy for compliancy. Then select the scope where the policy will apply. This can be an IP range address or one or more segments defined in the Forescout platform. For this example, we will use the predefined segment named Lab segment as the policy scope. In the main rules section, we need to define the condition for that policy to be applied. For our lab, we will not define any criteria in the main rule, so all hosts will be processed by this policy. And for the actions, we will create two sub-rules with different actions depending on the result of our health check. We can see that this policy, main rule and sub-rule are going to be checked on all admissions on the network and again every 8 hours. The first sub-rule we have is called quarantine. The criteria for this example is that if the host is running Microsoft Edge, it will match the quarantine rules. We are able to do this check because our host is running Forescout Secure Connector. The action that will be triggered in this case is a radius COA, which will contain in the filter ID attribute the value quarantine. The filter ID value must be associated with an access role profile, RP, on OmniVista. This configuration allows user roles within the organization to be assigned specific IPs, tailoring network access to the right VLAN according to their role. Our second rule is called healthy domain users and have no criteria, meaning that all hosts that are not running Microsoft Edge will be processed, and in this case, they will receive the CUI with the filter ID attribute domain users, giving them access to a different VLAN than quarantine. On that note, Forescout is a very powerful tool and offers a lot of possibilities for criteria and actions, with the possibility to add different actions per rule, meaning you could provide remediation on top of sending COA so the user can become healthy. Let's now see what we need to configure on OmniVista. On OmniVista, our first step is to add Forescout as an external radio server. To do so, let's go in the UPAM tab and click on External Radio Server. From there, click on Add and fill out your Forescout CounterACT information. Name, IP address, and shared secret defined previously on the Forescout platform are needed. On top of that, enable UPAM IP as a proxy for NICE IP and apply the configuration. The second step is to create your SSID, in our case, with 802.1x authentication, and select Forescout as a radio server. Go to the WLAN tab and click on SSID. Then add a new SSID. Choose a SSID for Enterprise Network for Employees, 802.1x. Authentication strategy, select Advanced Configuration. Here, you need to select External Radius as the authentication source and add Forescout as the external radius. To finish, save this new SSID and apply it to your desired IP groups. Our last step on OV is to create two access role profiles. Go to Unified Access, Template, and select Access Role Profile. Access Role Profiles assign specific security and quality of services policies to users upon network connection. These profiles streamline policy management by bundling rules and settings that can be consistently applied across different network segments. When creating the two IP, you need to make sure that they have the same name we have given to the filter ID attribute on Forescout. This is what Forescout will send back to OV in the COA. Once these two IP are created, you need to apply them separately to the desired device and map them to the desired VLAN. In our case, VLAN 125 for quarantine and VLAN 123 for domain users. Optionally, you can configure the period and location policy for this IP if you want to. Let's now go on our Windows client and Forescout CounterACT console to see the result when we try to access the network. From the Windows client, let's first demonstrate the scenario where the user is considered healthy, in this case meaning the Microsoft Edge process is not running. To start, I open Edge and make sure to end the process using the task manager. Next, I search for my SSID in the list of available WLAN network. Since this is a 802.1x network, I enter the credentials for a user from my Active Directory to connect. Once successfally connected, I verify the IP address assigned to the device using the terminal. The user is assigned the IP address 192.168.123.31, which corresponds to the VLAN map to the RIP domain users. On the Forescout console, I'm going to check the host details. Under the Policies tab, I can see that the host matched the posture policy, specifically the health domain user subgroup. Opening the detail of this policy reveals the rules that the host complied with and the action pushed by Forescout, in this case, the radius COA. Now back on the Windows client. After disconnecting from the SSID and opening Microsoft Edge, I'll try reconnecting to the network to observe the changes. Upon reconnecting to the SSID, the device is now assigned the IP address 192.168.125.32, which correspond to the VLAN map to the RIP quarantine. And returning to the Forescout console and checking the host details, we're going to see that the host still matched the posture policy, but this time it matched the quarantine subrule. In the condition properties, Forescout detects the MSH process running, which triggered the system to push the COA with the quarantine filter ID. And just like that, this is how we have demonstrated how Forescout performs 802.1x authentication with posture assessment using UPAM as a proxy radius. Before we wrap up, let's go over some key takeaways from this demonstration. First, a comprehensive integration. We've shown our ILE solution, OmniSwitch, OmniAccess Stellar, and OmniVista can seamlessly integrate with Forescout CounterACT. Together, they deliver advanced NAC capabilities. Secondly, enhanced security and control. This integration equips organizations with comprehensive device visibility, automated policy-based enforcement, and intelligent network segmentation. It's a complete solution to ensure both security and efficiency in managing your network. The third point is the valuable resources available. Make sure to check out our newly released application note. This resource offers a detailed guide on configuring and deploying the integration, along with key use cases. And finally, the strategic value. This integration adds significant value to our ILE portfolio, enabling us to deliver scalable, robust solutions to address the modern challenges in network security. Thank you for taking the time to follow this video. We hope it gave you a clear understanding of the powerful integration between ILE solutions and Forescout technology, and we're always excited to hear your feedback and see how you implement this solution in your own environment. So stay connected, and thank you again for watching.